we have graphically what we just did with two equations was if you graph both lines, where would they intersect? Right? So that's why you got an answer, a coordinate x comma y. The no solutions means they don't intersect, they're parallel. The infinite solutions meant they're actually the same line. So we're just going to take that one step further and say, where would these three planes intersect? Okay, well, they intersect at one exact point, and it'll be a triple, an ordered triple, x, comma y, comma z. Okay. We can still get infinitely many solutions where they can intersect all at a straight line. And there's actually three different ways to get a no solution. But in the end, it's going to be the same result. If you get something true, that's going to be infinitely many solutions. If you get something false, that means it's a no solutions. Which kind of no solution is not too important. Okay. There are all several ways for that to happen. All right, so we'll just practice. Now you can watch me do this first one if you like. Kind of get the knack of it. But basically, what we're going to try to do is use the idea we just finished solving two variables with two equations. We know how to do that very well. So let's turn this into that kind of problem. So if I can cancel out one of the variables with the first two equations and one of the variables in the second two equations, I will end up with two equations with only two variables. And then I can do the same thing we did last night. So the first goal is going to be new. The second part is going to be, okay, continue it. It's now just like a problem from last night. Here's what I mean. So let's take this and let's eliminate one variable from just these two. How can I do that? What variable can I easily eliminate? Okay. So let's see here. So I can't just add those, I can't just add those. None of them equals 0, so I have to multiply one of these by, multiply this one by either 2, if you want to cancel out, negative 2, sorry, if you want to cancel out the n's, or negative 3 if you want to cancel out the m's. It doesn't matter which way you go, so let's just say negative 3. So I have negative 3m. Alright. Negative 3 times there is going to be positive 3n. Negative 3 times here, negative 3p. And all the way over, it's negative 9. So 4 multiplications for distributive properties. Then, let's go ahead and add them up. So let me just bring down the first equation right here. I'm going to bring that down. So we got 3m minus 2n plus 4p equals 15. Yeah. So what do we have? N's cancel out equals 0. Alright, we'll have n plus p equals, what is that, 6? Alright, so we're kind of halfway there. We have one equation that has only two variables. If you just have one more equation that's like that, then you do what you did from last night, cancel them out. So we can do that. So let's do the same thing, cancel out the same variable, but with the last two. So with these two, we need to cancel, it has to be the same variable. So since we canceled out m here, we have to cancel out m here. Alright, so we can multiply the top by just negative 1. Right? And I'll say that's that. That's that. That's that. Alright, so I'm adding just these two together. So once again I get 0. This time I get 5n Okay, negative 6p and 0, negative 3 is negative 3. Alright. So goal 1 attained. I have two equations that had the same two variables. Now, you could have chosen from the very beginning to cancel out the p's. Just make sure if you did cancel out these, like if you multiply the bottom equation by like negative 4, that you would do the same thing here. You'd have to cancel out the p's, multiply the top equation by 5. So your work between each other could be different. You can just decide, not because your way was easier or harder, but just because you decided to cancel out a different variable. So just know that when you're checking each other's and working with each other's, you can take different routes and get the same answer. All right, and then from there, you have to do a whole problem just like last night, whatever you like to do. So let's cancel out what? I'll multiply this one by 6. So I'll have 6n plus 6p equals 36. 6n plus 6p equals 36. And what do we get? 11n equals 33, n equals 3. Alright. So here's where we're at. We have three numbers we're trying to get. M, N, P. Alphabetical order. So we have 3 right now. Just like yesterday, you would take this and plug it back in. Alright, so we have 3 plus p equals 6. 3 plus what equals 6? 3. Yeah. So we know that p equals 3. So my last number is 3. And now we have to find out what m is, the first number. We can take these two, plug it into any of the original equations. I think the middle one looks the easiest, right? So we can take n, that's going to be 3. P, that's going to be 3. So from this we have, we have minus 3 plus 3. So from this we have m equals 3. Yeah, they're all 3s. That's not a negative, that's just a straight mark. So they all come out to equal 3. Right, and the nice thing is, of course, we know if this is right or wrong. Let's check it. 3 times 3. 9. 2 times 3. Okay, so minus 6. 4 times 3. Okay. Does 9 minus 6 plus 12 equal 15? 9 minus 6 is 3. 3 plus 12 is 15. That's 1. Alright, 3 minus 3 plus 3. Does that equal 3?
Yeah.
Yeah, that's a little bit easier. 3 plus 12. Okay. 3 plus 12 minus 15. Does that equal 0? 3 plus 12 minus 15, does it equal 0? Yes. So we checked all 3. Has to work for all 3. I'd say that this isn't much more difficult than what we've already done. It just takes longer, and there's a lot, have to be more organized on your paper. You can see all these lines and everything everywhere. Just keep in mind that it's kind of like two separate problems. The first problem is really just to turn it into 2 equations, 2 variables. Okay. So you guys give it a shot. Practice 1. Work with each other, ask questions, help each other out. Keep in mind the organization on your paper does matter. Do not try to squeeze it in the bottom 2 lines of one piece of paper. Turn it over, give yourself half a page, just spread it out. Make sure it's neat so you're not, getting things wrong in math simply because of your penmanship or that kind of thing. Okay. Alright. Let's see what we get here. End up with x plus 3z equals 18. And 2x plus 3z equals 21. So these two we have to figure out now. Take that. Take my other one. There's my 2 equations with 2 variables. Right. So multiply the. I think we can just multiply the top one by negative. So I'll have negative x minus 3z. Make sure that's a z, not a 2. Equals negative 18. 2x plus 3z equals 21. And we get x equals 3. Not a 3. Oh. Alright, we're going x comma y comma z. So right now I'm here. If x is equal to 3, plug it back into maybe right here. Alright, so I get 3 plus 3z equals 18. 3z equals 15, so z is 5. Again, be careful with those z's. Make sure they look like z's. Z is 5. Alright. And now I can plug 3 and 5 into any one of these. I'll pick the middle just to keep it simple. So I have negative 3 plus y plus 5 equals 3. Put those together. What plus 2 equals 3? Y equals 315. 3 comma 1 comma 5. Let's see, if I check it, I'll get 6 minus 1 plus 10. That equals 15. That's good. The middle one I kind of just did. Negative 3 plus 1 plus 5 is 3. And the bottom one we have 9 minus 1 plus 10. 8 plus 10 is 18, so it does check out with all 3. Alright. Any clarification needed on any of those steps? You guys ready to give it a shot, or do you want to try another one together? Yeah?
Sure, when you got X, where did you get Or we put it in the equation where it's 3 plus 3z.
Right here. Or I could have plugged it into here. Yeah, one of my two variable equations. You can do either one. Just like last night, once you got an answer, you just pick it. I picked the one that had, just x already by itself as opposed to 2x and 3z. Less solving. But yeah, lots of different ways. So, in a nice, you guys finally get what you always wanted. Can I just do it this way? I know how to do it if I can just do it this way. It's like, yeah, now you really do it a lot of different ways. Unfortunately, it does make it more difficult to compare with someone else because they can take a completely different route from the very beginning, eliminate a different variable, and still the work will all look different, but it's still correct. So you guys can have two entirely different looking correct answers. As long as they both come to here, if you guys have two different answers, do the check. Okay? So one of you should be saying, my answer, I did a check, I know it's right. You don't have to figure out like all the work and see which one looks better. Just do the check, and one of them will work, one of them won't. And there you go, and you'll know what you need to change. Okay? All right. You think you want to do more? Just one more, or uno más? Should we do you guys? I just have two more. Yeah. Let's see. I don't like that one actually. Oh, this one's good. You guys talk me through it. Let's do that. New page. Alright. I have the benefit of this nice copy utility here. Nice to have it on your paper. So I need to eliminate the same variable in both of these. Alright. Strategically, is there one that's easier to eliminate than another? Not really. It's kind of the same thing, but we got to make sure I think x might be easier to eliminate here. So I'm going to have to do one multiplication. So let's make sure we eliminate x over here. So a little bit of strategy. Over here, easier to eliminate x, just multiply by -5. So that means over here, multiply by 5 and -2. Okay. So 10x, 15y, 20z equals 10. 20z. The bottom, -10x plus 4y minus 6z equals 0. I'm being really careful when I do this to keep the y's, the x's, and the z's and everything lined up in columns. Alright, over here, top one stays the same. Just copy that down. Top is the same. Bottom, -5x plus 25y plus 10z equals 20. So it has to be the same variable on both. 19y plus 14z equals 10. 23y plus 13z is 20. There's step one. Oh, those are almost all primes, aren't they? 19, 23, and 13, all prime numbers. So that would be the first way to go on these. So I just wanted to show you really that strategy Just set up the two. Decide what variable might be easier to cancel out from the beginning. If you just randomly choose, you might be doing more work, maybe not. Okay. And these will be actually somewhat difficult to cancel out just because they're all primed. We can't easily see, well, what goes into 19 and 23. We'll just have to multiply this side by 23 and this side by negative 19, and the numbers will get quite large. So leave that alone for now. All right, your homework. Let's look at that. Have it up on School Loop.